Okay, we're going to learn about significant figures. We're going to start with accuracy and precision because you should know this. Accuracy literally means the right answer. It's accurate. It's correct. Precision means it's precise, meaning repeatable. So the answers are close to each other. So 2.1 and 2.0, they're close to each other. So we can have values that are both accurate and precise. So it's the right answer and it's repeatable. So you can see some examples with actual measurements, and you could see what that looks like when we're talking about the dartboard analogy. This is in reference to a correct answer of being 1.000 kilograms. Same correct answer, so you could see that these answers are not accurate or precise. They're kind of all over the place. So now let's bring in significant figures. All digits 1 through 9 are always significant. So when you look at the first number, how many significant figures? 3. You just count how many digits are in the number. Okay? Right? When you don't have any zeros, easy peasy. Okay, let's just stop there. Let's stop learning rules and let's learn one all-encompassing understanding for significant figures. It's called the Atlantic-Pacific rule. So here's a quick little outline of the United States. The Atlantic side is on this side. The Pacific is going to be on the other side. So when you are counting significant figures, if there is no decimal point, so here, let me show you this. Here's how you do it. You go across like this, no decimal, no decimal, no decimal, no decimal. Oh, there was no decimal point. So now I'm going to backtrack and start counting this way. As soon as I get to a non-zero, start counting 1, 2, 3 significant figures. Same thing, let's look at this one. Go across like this, no decimal, no decimal, no decimal, no decimal. Okay, backtrack, start going back this way. Start counting when you get to a non-zero, 1 significant figure. And now let's look over on this side, and we'll do the same thing. So go this way. Oh, I see a decimal point. Reverse, reverse. Go back to the beginning and start counting as soon as you see a non-zero. Oh, there it is. 1, 2 significant figures. Let's do another example. So you start going this way. Oh, I had a decimal. Reverse, reverse. Go back to the beginning and start counting as soon as you hit a non-zero. 1, 2, 3, 4. Notice I counted that 0. Once you start counting, it's like you can't stop. You have momentum. Now let's look at measurements. Every measurement has an uncertain digit. It's an educated guess. Okay? So how long is this gray bar? Well, I know it's 3, right? 3 point, and now I make a guess. So halfway would be like here. So less than halfway. So let's say 3.3. This is my guess. This is my uncertain digit, but it's still significant. This one, well, I know it's 1, 1.1, 1.2. I know it's 1.2 for sure, and now I make a guess. I think it's a little bit less than halfway, so I'll say 1.24. The 4 is the guess. And this one, so it's 5, okay, point, and here's where it gets a little tricky. So if the bar went to right here, for example, I would say 5.14. I have 2 digits after the decimal. So I have to say 5.00 if I think it is right on the 5. Let's review calculations. Okay, you have to know rounding rules. So what I'm going to do here is round this to 2 significant figures. So I start counting, there's a decimal, go back to the beginning. This is 1 significant figure, this is 2. So to round this to 2, I look at the next digit. That's a 5, which says round up. There you go. Let's look at another example. I want to round this to 4 significant figures. So start looking this way. There is a decimal point, reverse, reverse. Go back to the beginning. 1, 2, 3, 4 significant figures. And then I'm going to look at this next digit. That's less than a 5, so I'm going to keep that, or round down, meaning I just get rid of this. Okay? When you add and subtract, you have to first do the addition or subtraction, keep everything left of the decimal point, and then the lowest number of digits after the decimal point. So here's just an example. You first do the adding, keep everything to the left of the decimal, and then for the right of the decimal, you have to look at the numbers you were given. This has the lowest number of significant figures afterward. So I can only have 1 digit after the decimal. I look at this, it says round up, so I get to this final answer. All right, when you're multiplying and dividing, what's after the decimal doesn't matter. You just look at total number of significant figures, and you want to have the lowest number. So, okay, here's multiplication and division. First you multiply. Then you go back to the measurements that you were given. That has 2 significant figures. This has 5. So my answer can only have 2 significant figures. So I start from this side. Oh, decimal. Reverse, reverse. Go back to the beginning. 1, 2 significant figures, right? So I look at this next digit. It tells me to round down, which means I get rid of all of this. But I don't want to write 92, because 92 is not how you round 920.58. That's not even close to it. So I need to add a 0 to fill that space before the decimal. So it should be 920. And that's it. That's a quick whew about accuracy, precision, measurement, and significant figures.